Hello everyone, we are building automated water sprinkler system. But why should we build it? Because water consumption is presently one of the more worrisome environmental problems in many areas around the globe. And our project therefore aims to solve this crisis by developing an automated irrigation system that can not only detect the fall in water level of the ground but also pump the required amount of water into the soil to sustain its fertility for a longer period of time.
Tinkercad model of automated IoT irrigation system.
This is our Arduino circuit of our project. The components that we have used are an Arduino Uno R3, a breadboard, a relay module, a soil moisture sensor, and a DC motor, a 9-volt battery. The working of our project goes like the sensor that is placed in the soil detects the moisture level of the soil. If the moisture level is appropriate, then the moisture sensor doesn't send any signal to the Arduino circuit. If the moisture level is low, then the moisture sensor sends signal to the Arduino, then to the relay module. The relay module then commands the pump to suck up the water from a water reservoir and fill the required amount of water to the field. Now in this Arduino circuit, we have used a DC motor instead of a water pump as it was not available on Tinkercad. So we made a replication of the pump and to show that how it works. So when the soil moisture is low, the DC motor starts operate. So if I start the simulation, here you can see that the DC motor is running when the moisture level is low. Now if I pull it up to the moisture, then you will see that the DC motor stops running. So this is the main function of the pump. The pump will do the same thing. If the moisture is low, then the pump will suck up water and fill it in the field. Okay. Now coming to the connections, we have connected the soil moisture sensor to the power of the breadboard and signal cable to the D6 pin in the Arduino. Input 8 of the relay is connected to D3. Here is the relay module. So the input 8 is connected to the D3 pin of the Arduino. And the fifth pin of the relay is connected to the negative terminal. So in the code, we have set the Arduino to set the pin to low when the soil moisture sensor sends high signal when the water level is more. This will turn open the relay connection, hence turning the pump off. When the soil sensor sends low signal, pin 3 is set to high, so the relay activates the pump, hence feeding water to the soil. Terminal 2 of the DC motor, terminal 2 is connected to the terminal 12 of the relay module, and terminal 1 is connected to the negative of the 9-volt battery. The positive terminal of the battery is connected to the terminal 6 of the relay module. The motor runs on the voltage supplied by the battery. Since this voltage cannot be controlled by the Arduino, we use a relay and set pin 3 to high circuit is established between the negative terminal. When the MINS actual circuit runs, then the relay sorts the terminal 12 of terminal 6 that is connected to the terminal 2 of the relay circuit, sorts the terminal 12 of the relay module which is connected to the terminal 2 of the DC motor, and terminal 6 of the relay module to the positive of the battery board, by which this DC motor runs.
This is the code for the project. Here we have set up pin D3 as the output, which will give output to the relay, and pin 6 as input, that will take input from the soil moisture sensor. Here we have set up the input received from the moisture sensor at pin 6 as water. Here we have made an if condition that will turn off the relay and turning off the motor when the water is high, or else, that is when the water is low, it will turn the pin 3 to high, hence turning on the motor. Components of the automated IoT irrigation system.
Here we are using Arduino Uno, which is connected to the laptop, and the code of Arduino IDE runs here. This is a 5-volt relay module whose one terminal is connected to the soil moisture sensor and the other terminal is connected to the DC motor. Now as the water level rises, the moisture sensor conducts electricity and it stops the DC motor.
Working of the project.
as you can see, the water level is very high, but when the water level decreases, the DC motor begins to work and it pumps water. And as the water level rises, the motor stops. As you can see, the motor pumps water when the water level is low. Now, as you can see, this soil contains less water content. Now, let us connect the Arduino to the computer and see what happens. As you can see, the motor begins to pump water to raise the water level of the soil. Now, as you can see, the water level goes up, it stops the motor to pump further water into the soil, and this is how it works smoothly and detects the required amount of water content of the soil. Now let us see thoroughly how it worked. Firstly, we have to connect the Arduino to a power supply, which in our case is through a laptop. Then it is connected to the 5-volt relay module, which is connected to a 9-volt battery and a soil moisture sensor, which emits pulses when the electrolyte from the water hits the plate of the sensor, and further the pulses turns into signals which then goes to the DC motor. And that's how our project works.